Aloha everyone, and welcome to another Carbon 60 video by me, Kay Elmer. And in this video I'd like to share with you my research into the concept of solvent free. And what I mean by that is the solvent free C60 powder that is added to oil that creates the C60 oil that many of us consume. So before I get into the content, let me just cover some disclaimers that this material is for research purposes only. C60 and C60 oil is not approved for consumption by the FDA. You understand that ingesting C60 is experimental and you do so at your own risk. I do not endorse C60 products. I don't have a stake in a C60 company, and I don't get paid in any way to make videos. This is purely my personal research that I willingly share with others. So let's jump in. So the first step in understanding the concept of solvent free is understanding the concept of how C60 is manufactured. So what the laboratories that make C60 and the producers that do it, there's three basic ways to do it. I'm going to start a little video here and I'm going to use that as an example, but the three ways is through electric arc discharge, which is what the video shows right here, another process called laser ablation, and a third way to do it, which is chemical vapor deposition. But the primary way is through electric arc discharge, where you essentially set up a vacuum chamber with an inert gas like argon, and you have two different probes, and the probes have a graphite rod, and then you run a really high voltage current between the two rods, and it creates an electric arc, which is essentially a lightning bolt. This thing gets up to about 4,000 degrees centigrade, which is essentially the temperature of the sun. So you can see why it's in a giant metal box and how it's glowing red when it's finished. But what happens is when that electric little lightning bolt goes between the two graphite rods, it essentially vaporizes the graphite into carbon atoms, and as they coalesce back in on themselves, they form different carbon allotropes, or different forms of carbon, anywhere from just plain old amorphous carbon, which is like soot, all the way up into the higher crystalline types of carbon like graphite, and also fullerenes, which C60 is one of. And so the output of the process of electric arc discharge, or any one of these three different processes, is called Fullerene soot. And essentially it's just this bunch of soot, black powder, like I would say, like printer ink powder, right? And that's what it looks like, and it's just this powder, and it's called Fullerene soot. And at that stage of the process, it's just got all different sorts of different carbons in it, and so and a percentage of it is fullerenes, and a percentage of the fullerenes, which is a class of carbon, is going to be C60. So the whole trick at this point is to how do I get from Fullerene soot, and how do I get it down to and actually getting the C60 out of the soot. So the next step is that they have to extract it, and the ways that they do it, and this is all non-industrial. I couldn't find any examples in video of the industrial processes. So the examples that I'm showing you here in video are just extracted off of YouTube, in which it shows how you would do it in a lab if you were just doing small samples. But the idea here is that there's two basic ways to extract C60 from Fullerene soot, and the one main method that almost most, I would say the majority of the literature talks about, the solvent method, in which, and this is an example, there's two ways to do the solvent method, which is one is using a Soxhlet extraction, which is what this is here. And so let me just stop right here. Basically, they take the soot, they add it to a solvent such as benzene, hexane, toluene, and they basically boil it. And as it's being boiled, it goes through kind of like a diffuser process here, and as it boils at different temperatures, it's going to essentially, it's like a distiller, it's going to distill out the different fullerenes based on different temperatures. And so that's kind of what the process would look like if you went into a lab and saw someone doing it on the counter. And that's using a Soxhlet extraction. There is another way to use solvents to extract it, and that's called a tetrahydrofuran sonication. And I believe this is the more of the process that the industrial folks would use, and they add this chemical to it that I horribly butchered the pronunciation of, and they sonicate it, and they basically do the same thing, which is the whole idea here is I've got to extract C60 from the soot, and you do it with chemicals, and you do it by either boiling them up or sonicating them off, and it leaves you with a powder like a C60 powder at the end. That's pretty much in a nutshell. Now the other way to do it is through sublimation, and that process is where there's absolutely no solvents used, and they simply just take this Fullerene soot and they stick it at the end of a quartz tube, and they heat the end up to like 600 degrees centigrade, and then they have this end is like cool, like I don't know how cool, but they basically heat this up, and then it vaporizes the fullerene soot back into vapor again, and then as the fullerene soot then moves down the vaporized fullerene soot moves down the tube, it coalesces at different temperatures along the tube, and based on where it coalesces, that's how they determine which one's C60, which one's C70, C84, and so forth. So sublimation is a very laborious and time-consuming process, which pretty much almost nobody does. You will always find that they use the solvent method. It's a much faster, and you can do it in very, very large quantities. So this is the primary go-to, and this is sort of how you would do it if you try to do it in your own lab. So now, as this thing, as I mentioned, as the extraction, or let's just call it distillation for simplicity, as it's being distilled, which is the soot in a solvent, as that's being distilled, okay, it's coming out at different colors. And so this, as an example, and this is from the book Introduction to Fullerenes. Oh, by the way, for anyone who's new to my videos, everything I'm bringing up as a reference, there's a link in the video description below if you want to do your own research, which I highly recommend. I'm providing you everything that I have read so that you can come to your own conclusions. Anyway, so going back to this book, and it's a great book. Introduction, it's not a book, it's a chapter of a book. Anyway, so I digress. So it comes out in different colors, and then as the colors change, then it indicates the difference between a C60, which is this color, and this is when it's in a solvent, okay? So when C60 is in solvents, it's purple, C70 is red, C84 and C86. So you can kind of see that as they're changing colors, they're pulling off those colors, and then that's what indicates which one is which. So it's really kind of fascinating, actually, learning all of this. So the next step, then there's more steps, right? This is why it's expensive. The next step is, now how do you purify that? So when you've got, let's say, a big giant vat of this, and okay, this is C60, okay, it's in this, here's some solvent like toluene, and then so how do you get it out of this solvent? And so what they do is that they evaporate it off. And here's an example in a lab of doing what they call a rotary evaporator. And so basically you would put your solvent with your solids dissolved in it, and you would put that in this little ball right here, and see this other ball? That's where you're going to run it through a hot bath, heat it up, evaporate off all of the solvents. The solvents go into that other ball, so you don't want to waste them. You want to reuse the solvents. And then what remains in this little end part here is a powder. And that powder is going to be in the, if it's purple, you start with purple, it ends up C60. If you start with red, it ends up C70. That's how you get the solvents out. And so that's what they do. They use that's what you would do if you're in a lab. I'm sure they've got some giant contraption in industry to do this, because they do it by the probably by the vatful. But this is how you would do it, and that's the concept. It's the same concept whether it's huge or large. You're still going to do it the same way. You're going to evaporate off the solvents, and then the next thing is you've got this powder. And so you've got the residual powder here left over from the evaporation process, and then they take that powder and they wash it. They usually wash it in ether. I've seen where they wash it in hexane, but the bottom line is they wash it off just in case there's any solvents left in there, because the solvents are pretty harsh, and they want to get those off, which is kind of funny because hexane's pretty harsh too. But anyway, the whole idea is whatever's left here after they evaporate it off, they wash it off to get as much of the solvent off, and then literally they take it to the next step on top of that, and they heat it in a vacuum oven, and they bake it for this is the thing that I could find no literature directly from the manufacturers that state what their exact vacuum oven process is. They just state that they do run it through a vacuum oven, and they put it in an oven that can create a vacuum, and then they heat that puppy up. And then as that thing is heating up, any solvents that are remaining in the powder are essentially just vaporized off. And then, of course, there's this whole thing about you don't want to heat it up too much or you're going to mess up your C60. So when you're done with this process, you have what they call solvent-free C60, and that's what it looks like. This is a sample of one of the C60 powders that I have right now in my possession, and so that's what it looks like when you're done. Okay, so that's considered solvent-free C60, oven baked, right? So you see when you're out there purchasing C60 oil and or raw C60, you will see the words vacuum oven. You will see the words solvent-free you will see the words pure, and what those all mean is that it's gone through all of those processes to basically get all of the chemicals out, and so that it's just C60. Now actually in the word pure, they take it's kind of used in an extra step, because as you know, try to imagine taking out the liquid when it's running between purple and red. And so they get kind of like that there's some red in here and there's probably some purple in there, right? And so by the time they get here, the idea of purity, just as a sidebar, when you see purity of like 99.95, that has nothing to do with the solvents. Purity is specifically related to the percent of the powder that has C60 in it and what percent doesn't. So as an example, if it's 99.95%, that means the residual powder, whatever's left over when you're done, this powder is 99.95% C60 and 0.05% some other fullerene that got kind of stuck in there when they were doing this. And so that other fullerene is usually like a C70, C84, exactly. You saw the example. But that's what purity means. So there's a lot of different words are being used. I think that the manufacturers who produce the actual C60 powder are by far, that's their industry, and they're very sensitive about how they use verbiage. But what I read when I look at products that are out there, especially the newer vendors coming out that are making C60 oil, a lot of them are confusing their terminology. And so I'm just, hopefully this helps people understand what those words mean. And then if you're interacting with someone and you're purchasing 60 oil from them, it'd be kind of a good idea to ask them how they're using those words. So anyway, so that's what solvent free is. So the purpose of this video, and thank you for sticking around for this length of intro, just so you understand where I'm coming from. But the purpose of this this video was, I just kind of was like really interested. I see the word solvent free all the time, so I was thinking, how solvent free is C60? Actually the question is solvent free C60 solvent free, right? That's the question I had for myself. So I did find, because the idea here is that because here's this, let me just jump back. After this is done, that's when they sell it to you and me and make C60 oil themselves, okay? So my question was, well, does anyone test this to make sure that they got it all out? I mean, they go through this laborious, process to get it out, but, do they test it? And I'm sure somebody went out there in the world did test it. So here it is. I found 2 studies that actually groups of scientists took the commercial grade C60 that's sold, when they just go through all that process. Here you go make some C60, and boom. So now here's the 2 studies, and I want to review the what the studies were and what they found. So the first study, I'd like to point all of you to a book called Physics and Chemistry of Fullerenes and Derivatives, an exciting free read on Google Books. And in this book, on page 48, is a study by a group of scientists, and the study is called The Evolution of Species During Thermal Sublimation of C60. Now, I just want to point out real quick here that the word sublimation means take the powder and heat the crap out of it, okay? So this is not C60 being processed using the sublimation method. This is sublimation meaning like heat it up. Okay, so that's what they did. So, again, always the words that people use gets really confusing. So the abstract for this paper, essentially what they did was they went and purchased commercially available C60, and they just put it in a vacuum oven, and they hooked up a whole bunch of different things that could watch it and measure it and evaluate the C60 as it got hot. And instead of going up to the normal range, they took it all the way to 1,000 degrees centigrade. So let me just show you what, quote, normal range is. As I read this paper, I kind of just created this little chart to show you what happened as they turned up the oven. So and then they measured the results. So that's what this group did. And so now the materials and methods for this experiment was they purchased, again, like I said, commercially available C60. It was 99.9. They produced it. It was produced through electric arc discharge and purified with toluene. Okay, so that's exactly what you and I are all going out there buying. We buy a little bit better purity, but you know it's really 99.9 is fine. There's actually plenty of people out there making C60 oil with this. So anyway, so they heated it in the vacuum chamber, and this was the setting at 10 to the -6 torr, and then they started from room temperature and they took it all the way up to 1,000 degrees centigrade. Now, these are the tools that they use to monitor the changes to the C60. They used a residual gas analyzer, a mass spectrometer, and an X-ray diffraction. Sorry. So here's what happened. As they heated up the powder, all the way up to 300 degrees, they did not see, these they were watching for, they did not see any traces of toluene. Okay, and that's very consistent because everything that powder had gone through before they got their hands on it. And then here's the question that I told you about, where I couldn't find the literature. Is kind of like anywhere between 0 and 450 degrees centigrade is kind of like, quote, the vacuum oven process. So different labs, different companies do different things. Some twice bake it, some take it to 350, some take it to 380. So there's really no clear way. I couldn't get that data, so I'm just but I know that it's in here. So vacuum ovening of the original, like the first run, I guess, is anywhere from 0 to 450. So that's kind of what the range is. So when the scientists started cooking it or baking it, they took it up to 300. They didn't see any sign of toluene, which is good because it's solvent free, right? But here's what happened. After 300, they started seeing toluene being released from the C60 powder. And then it started to come out, and you can read the study, and it came out, and then around at 600 degrees centigrade, the toluene peaked out. I mean, the solvent, toluene, peaked, and then it started to go down. So what that means is that there was toluene in the product, and that it showed up, baked off, and then went away as they turned up the oven. And so, there was toluene still in the, quote, commercial product. And then what was most interesting, this is what's really interesting about this study, is that they found benzene. And there shouldn't have been any benzene because they didn't use benzene. So what happened was, and they kind of guess at why, that they saw benzene, and they saw benzene show up around 500, 550, and then peak out at 700 degrees centigrade, and then go away after that. And so they discovered in the sample that they tested toluene and benzene that shouldn't have been there. And then the other thing I want to add just to this is that within the study I learned something new, is that, I didn't know this, right? But I learned that, this is the range of temperature for vacuum ovening. And then what's real interesting is that the reason that they stop right around here, around 450, is that if you take it past C6 or 650 degrees centigrade, the C60 becomes inert. It becomes insoluble. So you have this crystalline C60 powder, and if you heat it up too high, anything over 650, the C60 becomes insoluble. It won't dissolve in anything, and it just becomes a kind of a different type of a molecule, I guess. I mean, I'm not really clear on that. I'm not a chemist, but that's what it said. So what that implies to me is that when you're doing a vacuum oven process, you can't get to these temperatures because you don't want to get anywhere near the point where you destroy your product, right? That's what that means to me. So I'm just a layman, armchair, scientist kind of guy. So that's kind of a very interesting study, and this is what they found in that study. The conclusions were simply this: that they found that by removing part of the solvent by thermal treatments, which is what they did, it reduced the amount of residue to about half by weight. So that means they estimated that there was about half that they were able to get out of the sample the first run. And the first run is, here you go, we're going to sell it to you. So that was kind of interesting. And then also, too, they hypothesized that the benzene ring that they discovered in the process, they expect that it could either be a byproduct of the polymerization reaction or a product of the pyrolysis of the polymer. I have no idea what that means, but I'm just putting it there because it's so fascinating that they found benzene. And for any of you chemists out there, maybe you probably know what that means. And then here's what's most important, is that the detection, and these are all direct quotes right out of the study, the detection and analysis of the volatile species, which is the volatile, that means molecules, during the sublimation of pure C60. And it was actually sold to them with the word pure, which is interesting, show that toluene and other species related to the solvents used during the extraction and purification of the material is present in the commercially available pure C60 up to a temperature higher than 600 degrees centigrade. So there you go. This is a study that says that the solvents remain. So here's the second study, and this is a study called Solvent Molecules in Crystalline C60 that's published by the American Chemical Society, link in the description below. And this study was a little different. Instead of taking the C60 that they obtained, commercial C60, and instead of baking it and seeing what comes out of it, they simply just measured it. They just took a bunch of different processes, and then they studied it to see what was in it. And so, sorry, getting a little hoarse here. Thank you for waiting. Needed some water. Okay, so So they basically took a look at it and they evaluated it as a substance. So the materials and methods for this method was they actually created, or they obtained 6 different samples prepared by different procedures for the experiment. Samples B1 and D1 were C60, that was vacuum evaporation of toluene solution washed in hexane. So if you recall from how you make it, instead of using ether, they washed it in hexane and they put it in a vacuum oven. So that's what we buy, right? We buy stuff that comes out of the vacuum oven. And then this was the equipment that they used to measure the product that they had gotten, which was they used X-ray diffraction, spectrometry, differential scanning, and gas absorption. So these are the tools that they used. So the results here from this group of scientists in this study was the very first thing that just pops out at the page from when I was reading it was that the spectroscopy, sorry, the data gives the evidence that prolonged vacuum heating of the sample fails to remove completely the solvent molecules from the fullerite. And they're calling it fullerite versus Fullerene soot, and there's a distinction. Fullerite is a term that scientists use for a substance that has C60 and C70 in it, and then Fullerene soot is the soot. So they got a sample of fullerite, which is still the end product of the manufacturing process, and that's what they were using. So that's what the word fullerite means. And so then upon prolonged heating, there's a possibility of, and this is what's interesting, they theorized, I guess is the best word, that how this is possible. I mean, how could they take a sample of fullerite, and then find that there was basically solvent still left in it? And so this is what they believed was happening, is that as the vacuuming process is happening, so upon prolonged heating in the vacuum oven, right, at the end of the process, that there is a possibility for the microcrystals of the C60 to be sintered. In this case, some of the solvent molecules can be entrapped into cavities inside the sintered microcrystals. So what that means is that, and this is what's pretty crazy, right, is that the actual process of using a vacuum oven at the end of the manufacturing process is what causes the solvents to get trapped, the residual solvents to get trapped in the C60. Again, it's stuck inside the crystals that are formed. So it's very interesting that is the process that makes it happen, when that's the process that people use to get rid of it, right? So kind of surprising, very interesting stuff. And so now the conclusions for this paper, and then I'll just highlight the one that's most important, is that the sintering of the microcrystals upon heating is assumed to be responsible, and this may be the reason that solvents cannot be completely removed by vacuum heating. Okay, and that only sublimation makes it possible to obtain virtually solvent-free materials. So now, different uses of the word sublimation. I want to point out in this example that they're meaning that doing it this way, which is no solvents used, versus doing it solvent, is what they're saying as to why that it's the only way, that this is what they theorize, that it's the only way that you can actually get solvent-free is not to use any solvents, because you don't get them out the other way. So this is a lot of just kind of interesting information about the fact that the C60 that is being used to make C60 oil has some residual solvents in it, obviously. And I don't want anyone to be concerned at this stage, because there's a lot to be thought about in terms of, okay, well, now the studies found that it's got solvents in it, now what, right? So what are the implications of residual solvents in C60? So this is where I rooted around, and I looked at the OSHA regs, the EPA regs, the FDA regs, and said, okay, well, let's be honest, everybody. I mean, there's chemicals in everywhere. There's chemicals floating around in the air. I mean, just driving to work, you're getting subjected to all that carbon monoxide and who knows what else. Air's got chemicals. The food's got chemicals. Ever looked at the ingredients list on any commercial product of food? I mean, you can't even pronounce half the stuff that's in there, right? The preservatives are chemicals, and then everything. Everything has chemicals in it. So how do you even understand or even begin to understand, okay, what does that mean? There's some solvents in C60, and how honestly, how big of a deal is that? So the only thing, and this, that I found, and I did this for quite a long time. So the closest thing that I could find was the FDA guidance for industry regarding residual solvents used in drug products marketed in the United States. And so in chapter 467, it's called Residual Solvents. I took a look at what the FDA has to say. That's the United States Federal Food and Drug Administration. Okay, for you guys that are outside. That's our government body that regulates foods and drugs. The EPA here in America is the Environmental Protection Agency, and that's the part of the government that monitors the environment. So they're more worried about breathing stuff, getting stuff on you. The FDA is more worried about, okay, you ingesting it or having it injected in you. So those are the two distinctions there. Anyway, so now I just want to just point out, and I've linked it below. You can read the whole thing. But the whole idea here is that because this is right out of the chapter, because residual solvents do not provide therapeutic benefit, they should be removed to the extent possible to meet ingredient and product specifications, good manufacturing process, or otherwise quality-based requirements. So in a nutshell, they break out the different chemicals that are used in processing drugs. And I know that C60 quote is not a drug, but they use the same chemicals, right? So this is my apples to orange kind of apple comparison, but they basically state in this guidance that class 1 types of solvents should be avoided, class 2 should be limited, and then of course there's a third class of solvents that should be used where practical. So they break out the different solvents, and they basically did all this study and they figured out class 1, really, really, really bad. Don't use it at all if you can't. Absolutely don't do it unless the benefit of the drug is so superior that it's worth poisoning the patient, and that's called chemo, right? And then class 2 should be limited. So in other words, like you can only have so much in it before they consider it to be dangerous. So when I take a look at the FDA guidelines and I measured that, or not measured, but compare that to what these two science papers came out with. And this is the thing. These two papers, they didn't do a parts per million analysis. They just did an analysis, and they did it in different ways. So I had to and this is some really rough and tumble math, okay? So I want to caveat this slide by saying that there's probably a significant error rate based on the difficulty of trying to take statements or this type of data and convert that into parts per millions. So do not take this at face value or the or gospel. It is an approximation, I guess I should say. So now they stated clearly, and this is a quote right out of this paper called The Evolution of Species in the book, 3% by weight of the initial load is what they estimate the residual solvents to be, and that 3% is unbelievably large. And they had to calculate that because they were using, they were measuring it as they were baking it, right? So if that's true, then it's like 300,000 parts per million, and which I find unbelievably, like, it's really hard to believe that would be the actual number. But after all that stuff, that the industry professionals go through to try to produce as clean a product as possible. I just think that this is kind of a really high number, so more research required, right? So, but this one seems a little bit more realistic, which is the study called Solvent Molecules in Crystalline C60. Now, what they actually, because they had all those tools, they measured it, and they actually have a table in the paper where they measured what they called the hydrogen to C60 molar ratio, and so they found it to be 0.051 to 0.21. And what they mean by hydrogen is C60 is just carbon atoms, 60 carbon atoms. You know that, right? But all solvents have a hydrogen bond to carbon that makes them, what they are. So like the benzene ring, hexane, and all these different are considered hydrocarbons. Okay, that's so they're measuring the hydrogens. They were measuring hydrogen in relation to C60 molecules, and this is the percentages that they found. I tried to do some rough and tumble translation here, and that kind of comes out to anywhere from 510 to 2100 parts per million based on their measurements of the residual solvents in the C60. So when you take a look at that federal FDA guidance of residual solvent limits, what it states in there is that the benzene is just a class 1 solvent. The limit on that's 2 parts per million. Toluene is a class 2, hexane is a class 2 solvent, and those go at 800. This is the limit now that the FDA guideline says that it should be no higher than 890 for toluene and 290 parts per million for hexane. So you can see right here, and just this right here, I'm going to disregard this guy. It's just too far out there. I mean, the variance is way too high. So this is, I'm going to kind of just comment on this. As you can still see that even with a reasonable amount, a reasonable number coming from an actual measured sample, that the parts per million is sort of exceeds the FDA guidelines for drugs. So it's something to take into account. It's data. This is science. Everything is data, and so we go from there. So now that we know that there's been 2 studies, and I want to quantify. This is so important. We do not know that there is solvents in all of the C60 products. I'm sorry, the C60 powders that are being sold. We don't know that. You know why we don't know that? Because nobody tests each batch and puts out, like an analysis, just like they do with the HPLC analysis that shows, that it is C60. Well, there should be this other analysis that says, well, how clean is it, right? But so we don't know. Nobody knows. So there's no way anyone could make a statement that says there is solvents. But what we can say, right, based on these 2 studies, is that they found solvents, which is way different than saying that there is solvents. So scientists have found solvents remaining in the C60 that is being sold. Okay, so here's some considerations. I've been chewing on this for a couple of weeks. It took 2 weeks to read through all the material. I printed out, it's about 2 inches thick. So it took a couple of weeks sitting in the dog park, reading all this stuff day by day. And I've been chewing on it, so I wanted to share with you the considerations that popped up in my head and my thoughts about this situation, because it is a little bit alarming for those of us who try to avoid chemicals. So the first consideration that I thought about, and I'm just going to do a little bit of brainstorming here with you, is the first thought. My first thought was, wouldn't the C60 mitigate the toxicity of the residual solvent, right? Because C60 is an electron donor, toxins are electron stealers. So you've got the solvent in the C60, so that if you mix it in oil and you ingest it, right, wouldn't the C60 be gobbling up the toxins in the oil that's mixed in there with it, right? And so obviously the answer is yes, it would. But here's the thing: there are no studies, there's no data on anything that could tell us, how much is actually being. So let's say there's 100, let's say there's 200 parts per million of the toxins going into the oil along with the C60. Of those 200, how much of that is being gobbled up by the C60 itself, and how much of the rest of it is going into you, and so. That's the thing. Yes, it does, but how much? I have no idea. There's no way to know. And then the second consideration that really stands out is, what about my first thought was, wow, the whole point of everything we're doing about C60 is because of those toxicity studies. The rat study, by the way, has been duplicated, and there's been studies done on dogs and fish and all sorts of things. And all of those toxicity studies is how, that's what they were done. They were toxicity studies to see how much C60 would kill something. It didn't kill them, and they live longer. So what about all that stuff? And so, I read through that again. I went back and looked at that stuff, and sure enough, the studies that were done for toxicity of C60, they measured they dissected the animals, except for the dog study, and they dissected the rats, the mice, and so forth, and they looked for damage. They looked for damage in liver. They looked into, for all the various organs, and they basically, they basically came out with the studies that we all know now, which meant, hey, C60 is not toxic. But the solvents are, so let's keep that in perspective. So they didn't show any damage. But here's the thought that as I read through the material, this is the thought that really occurred to me, which was like, okay, that's all good. That means that if you take C60 and you're a mouse or a rat or a dog, and you take it for a short time period, and you're good to go, which is good, because we've all been taking it probably most of us less than 2 years. The longevity guides have been taking it for 6 or 7 years, but for the most of us, we haven't been taking it too long, and so it's like, hey, we're like the little rats, we're fine. Hopefully nobody dissects us to prove that, but hey, we're okay. So no damage, right? But here's the thing: there haven't been any long-term studies, so it's unknown. So it's like one of those unknown knowns, right? You don't know, because nobody has taken C60 every single day, a teaspoon or a tablespoon, for years and years and years. And that whole thing about this part, like unknown how much gets through, it's just unknown. So it's another unknown known, or no, what is it? Known unknown. So so there's an area here that when you say, what about the toxicity studies, you're like, well, I don't know. There is no way to know. Because it hasn't, remember, they only put out that study, the rat study, in 2012. It's 2019. It's only been 7 years or less, right? So it's still unknown. And that's the thing. There are no long-term studies. And, and just like an example, the rat study itself, the Paris rat study, that study went for 5 years on rats. And then the rats weren't taking C60 every single day for 5 years. They took a whole bunch for the first week, and then they took some every other week, and then they took it every other month, right? So they didn't take it every single day. So there has been no studies, which is my point, of critters taking C60 like we do, which is every day, for years and years and years. And even the Live Pet, they had 2 clinical trials on dogs. You can read about that on their website. And those 2 clinical trials, one was 19 days and the other one was 28. So there's, and the dogs were great. They were perfectly fine. So yeah, you can do it in the short term. But what would happen if you had a dog that lived 9 years and you gave it C60 every single day for 9 years? We don't know, right? So therein lies the question. So the other consideration here is, what about all the positive testimonials? And that's where, yeah, absolutely. You, me, everybody, we're all taking C60 and great things are happening. And so, and so that's goes back to this right here, right? Is that there's you're still getting the benefit of C60. You just got this little thing that's coming along with it, the residual solvent, but you're still taking C60. C60 is still doing magnificent, great things for us. And so it's like, okay, well, it's kind of, the whole idea here is that that there are obviously the positive testimonials is because that there's so much C60 when you take the C60, and that the residual solvents are so minute in quantity. So clearly C60 is, and the solvents are 2 different things. They come together, but people are obviously having very positive experiences with the C60. However, and there's always a however, there have been negative reports as well. I'm not sure if you're like me, but I watch every video that comes out that talks about C60. I read everything I can get my hands on about it. And so, there have been numerous, and I'm saying that when I say numerous, I mean more than a dozen, of reports that I've read where people took C60 oil. And you know what? You don't know if it was the oil. You don't know if it's the residual solvents. But they had bad experiences. A lot of those comments, they use the word brain fog. Other people get nauseous. There's reactions, and you don't know. Again, I don't know if it's the oil or the solvents, but there are negative testimonials, and so we all seem to focus on the positive news, but there is negative news as well. That's my counter to that consideration. And then the other one too is and this is the other thing was, isn't the volume negligible, right? Given all the toxins we're exposed to. I brought that up a second ago, and the answer is it's untested. And I'm unqualified to judge. And so what I mean by untested is no one's tested what happens again, right? If you take the residual solvents for 20 years, so we don't know. It's a known unknown. And again, I'm unqualified to even comment on that. I'm not a biochemist, and so we just don't know, you know. And the whole idea about all the other chemicals in the environment that we ingest and breathe and drink, well, here's my thinking. A lot of people who take C60 are taking it to detox, to get rid of all that stuff. So if you're taking something to get rid of chemicals that has chemicals in it, you know, you have to think about that, right? So but you know, it's not tested, and I have no idea. I have no way to, you know, address, or any of us, there's no way to find the answer to this question because it's just not been studied. So then the other issue here is, do the manufacturers disclose this information? That the idea of it being solvent-free is not really solvent-free, as you and I would probably use that word? And the answer is yes. That they actually do disclose that this issue exists, but they don't come out and say exactly as I'm saying here, showing you in these two studies. But if you take a look at the material safety data sheet and the disclaimers that are used out in the industry, it's pretty clear that, you know, solvent-free is not truly solvent-free. So I'll show you that in a second. And then the last thing, too, that just popped in my head right before I started to record this was FDA guidelines, really? Yes, okay, for all of you that know what I mean by that, yeah, you know, yes, I know. Because what I mean by that is the FDA guidelines is a heck of a guideline to use, but I got to tell you guys, it's the only thing I could find, all right? So, you know, cut me a slack. But the FDA is also the same government agency that has no problem with letting people put aspartame or MSG or any of those other. I mean, take a look at cosmetic products and the amount of lead that's in there, and you know, just you look at like underarm products, they put in aluminum. I mean, really, aluminum? Do you know what aluminum does to you? And so they put all this stuff, chemicals and harsh metals, into consumer products every day, and the FDA is like perfectly fine with that. Okay, I'm sorry, I'm going on a rant. I need to stop. So yeah, so in other words, I know. Okay, so I'm going to go back to now this one here. I apologize for that rant. I just can't help myself. But anyway, so yes, let's take a look at the material safety data sheet and disclaimers. I just want to show you just a couple of examples, and I swear I am not picking on anybody, but I just went to the top 2 C60 producers on planet Earth, the absolute most respected, the most professional, and it's Sigma Aldrich and it's SES, okay? Now, these two companies are just by far the, you know, they're like, you know, the one everybody measures against, okay? And so, but they both put out a material safety data sheet on the product, the C60 products that they sell. And so here's Sigma Aldrich. And they sell it, you know, this is their top of the line C60 product. It's 99.9%, and they say it's sublimed, okay? Y'all remember what that means, right? And then here's their material safety data sheet. So if you go and you click on this thing, and it pops up, and it's GHSO7. And so this is what they use, and they just go visually. And then right here, boom, right, the first thing it says, acute toxicity, oral dermal inhalation. So in other words, category 4. So they're selling a product that they're telling you, don't take it, you know, don't eat it, don't put it on your skin, don't breathe it in, bad. Right? But does anyone ever read the fine print, you know? But then again, you all remember that there are no safety studies, you know? I mean, there's toxicity studies on mice. There are no human trials. This is not FDA approved. This is what you see when you buy it if you read the fine print. And essentially, it's them being very upfront with you, saying, you know, hey, it's not tested for that. So, you know, this is our safety sheet, because there's no other toxicity data available. So they have to go and report this is what happens. And then, of course, I went and looked at multiple sites, and the only place that I could find any even the remotest transparency on the concept of solvent-free was SES. I mean, Fullerenes, they talk about it being like purified, but they don't use the word solvent-free, but they also don't say anything about residual solvents or that. You know, there's no disclaimer, right? But SES, when you look at their website, they use the phrase solvent-free, and they have an asterisk. Okay, that's your fine print, folks. You go check out what that asterisk means, and this is word for word on the website. It says, in regards to solvent-free SCS C60. It says, result is less than the reporting limit, but greater than or equal to the method detection limit, and the concentration is an approximate value. And then they quote this acronym and these numbers. So what does that mean, right? And so, you know, it's kind of like a way to say, well, and this is my interpretation. It's not free, right? It's not free. It says it's anywhere between this, and we use this as the method. So I looked up 8260B. If you type this into Google, it pops up something called Method 8260B. It's an 86-page procedure manual on how to test. And so basically they're saying they tested it, and it's like, you know, this is what the results are, and they can't, and there is nothing that actually says that it's a zero. And so, or that's my guess. I'm guessing now. Sorry, try not to guess. So, but this is the disclaimer. So I just, you know, again, I want to point out, solvent-free asterisk does not mean solvent-free. Okay, and then of course, you know, we got those two studies. So, in conclusion, clearly, more research is vital to all of this. I mean, you know, again, it's only been going on for 7 years. We are the human trial. I mean, I can't stipulate that enough, but there definitely needs to be more research. 2 studies is not enough to form a solid opinion as to whether or not the C60 that's created through the solvent method is safe. Or it affects us. I mean, obviously it's safe, we're all taking it, but how does it affect us, right? That's the question. The other thing is that we need more data, right? There's more data about all the people that are taking it, and what are the human trial? What are they experiencing? For those people that are having adverse reactions, what were the conditions by which they were having adverse reactions? All the ones that are having positive ones, what are their conditions? I mean, we need, you know, that's the thing, that's the trial, right? So we need more data, and we need more transparency, right? Because, you know, this is transparency, by the way. But do you see anything like this on all of those vendors that are selling C60 oil? Right? And the answer is no. You do not see that. And what I see is a whole bunch of folks making C60, selling it to the general public, and they're not even disclosing the fact that that the powder that they're using has these disclaimers on it. Those disclaimers should carry forward. Well, I mean, let me back up. There are some vendors that I have seen, they actually put out there, they literally go, not meant for human consumption, don't eat this, you'll die. You know, I'm sorry, I'm embellishing. But the whole idea is that there are vendors selling oil that make sure it's very, very clear it's for experimental purposes only. But a lot of the new ones, right, not the ones that are established, that have been around for years and years, but the newer ones are coming out, and they're all fluffy, and it's like, oh, it promotes longevity, you know, and all. And it's like, wait, whoa. We're still in the pre-human trial. Okay, you can't be, you know, don't be saying that stuff when all this stuff is available when you bought that powder and then made your product. Okay, so let's just be perspective, transparency, everybody. Okay, and then the other thing is more caution. You know, these 2 studies show, they found, right? That doesn't mean everything has it, but they found solvents in the C60. So caution, transparency, more data, and research. And I think the piece about the more data, and I just want to add this last thought before I jump into my opinion. The last thought I had, you know, sitting on the dog park bench, was that why would there be negative reactions, and why would they be purely positive and purely negative, and then there's also the ones that have no effect at all? So that's kind of like, I mean, you can imagine how many testimonials I've read in the last year and a half. So I've read a lot, and that's how it breaks out. You're either positive, negative, or neutral. And so I'm thinking, you know, why would there be negative? I mean, how could I take C60 for a year and a half and feel nothing but positive benefits from it, but other people going, hey, you know, I just, you know, they report brain fog, or they report nausea, they report headaches, and so forth. And so I just think that it's like anything else. And okay, I'm going to jump into my opinion. This is my opinion why I think that's happening, and I think that certain people are genetically disposed or predisposed to sensitivity towards chemicals. I am one of those people, by the way. I don't know if you've ever heard my MSG story, but I am very much an individual that when I ingest MSG, that little white powder crap that, you know, every Oriental restaurant seems to just dump stuff into food, and it's you know, it's in everything. But it's also called monosodium glutamate. But it's a neurotoxin, and whenever I eat it, I have a horrible reaction to it. I mean, it is break out in rashes. It affects my brain in a very negative way. It lasts for days, and I just have this really bad reaction to MSG, and it is a pain in the okole, and that's a Hawaiian word for you can imagine, to have to deal with that. And so I avoid MSG at all possible, because I've been like that for 10 years. And then now that I'm taking C60, that's my story, is now that I'm taking C60, when I take in MSG, it doesn't bother me as much, so I know that the C60 is working, right? So, but I am predisposed to be extremely sensitive to a particular chemical, MSG. So that means that, just based on my own personal experience, that means it's perfectly reasonable to expect that other people would be very sensitive to toluene, hexane, benzene, and all these other chemicals that are coming in as solvents. So that obviously is my first thought, why there are so many negative ones. And then at the same time, when you look at people who are going through cancer and they're immunocompromised, and, if you're taking C60 because you want to detox because you're really messed up and sick, then taking in a detoxing agent like a C60 that has residual solvents, probably not a good idea. It's just my opinion, right? But if you're healthy, and I'm fairly healthy, taking C60 does just wonders for me. So that's kind of like what I was thinking, and I just wanted to share that with you at the end of this video. Otherwise, my other opinion and my perspectives here, I just want to, because I know people are going to ask me, am I dissuaded from taking C60 now that I've learned this information? And I just want to say, absolutely not. I am a pro C60 individual, as you can imagine. It does really wonders for me, and so I am not dissuaded at all. I'm not stopping taking C60. I've got multiple different batches upcoming videos about different ways to take C60, and so I haven't had any adverse reactions, but I am also concerned that there's no long-term study. So, if anything, that what I've decided to do was I decided to ramp up my detoxing regimen. And I already do a lot of detoxing, and C60 is just one of many different things that I take on a normal daily basis because of our environment that we live in. So I've just really kind of, ever since I read all of this, I decided, I'm going to just really ramp up my detox regimen to just in case, right? So, and that I just want to be honest with you guys. And then, should you be? Well, that's kind of like everybody's going to make their own decision. But I just wanted you to know what I'm doing and how I think about it. And that, no, I absolutely do not think that it's that I should stop taking. That's, to me, that would not happen. But I really think that if you are in a weakened condition, you need to think twice about it, because now, if studies have found that there are residual solvents and they are above the FDA limit in parts per million, and you are immunocompromised or very sick, you probably don't want to participate in the human trial. That's why every company says, if you're pregnant or you're a child, do not take C60 no matter what, because they just don't know. And you don't want to join a human trial if you're sick. Okay, it's common sense. So if you're sick, you want to take something that's got a little bit more research behind it. All right, so that's it. Thank you. I'm sorry for the very long video. This is a pretty intense topic, but I just want to say thank you for sticking it out if you made it this far, and just and exploring this subject with me and listening to me talk about it. I really appreciate your time. I know you're busy and you've got a lot of things going on, so thank you very much for listening to this video, and I do appreciate your patronage and your kind words. So thank you very much. Have a great day. Last thing, if you got any questions, again, for the makers group, if you want to make your own, and yes, I keep making it. I've got batches stirring right now. So, if you got any questions, please just, go join our chat group. We're more than happy to help you out. All right. So thank you very much. Have a great day. Aloha.